what you're going to do is anytime you see the word smooth pulley means that friction does not affect your pulley. So you always draw a pulley as a You always draw a pulley as a circle, okay? Now, what you're going to have coming down from your circle is two lines that go through the circle, and you're going to attach these to two weights. With two weights is 1 kilogram and 13 kilograms. Doesn't matter which one I put where, so I can say the left one's 13, the right one's 1, or the left one's 1 and the right one's 13. It really doesn't matter, okay? So that's 1 kilogram, that's 13 kilograms. Now, what do you predict to happen here once we release the system? That one goes flying upwards, this one goes flying downwards, okay? Because they're connected, what do they definitely have in common? Their speed and acceleration has to be identical. Reason being is that provided the string is always tense. Because they're getting connected to each other. It's like towing something. It goes the same speed you go, it undergoes the same acceleration you undergo. So in the 1 kilograms case, the acceleration is going directly upwards. In the 13 kilograms case, the acceleration is going directly downwards. Now, what works against it in both cases? Can anybody tell me what's working against? So what's working against their weight? So the weight of the 1 kilogram mass is 1g. The weight of the 13 kilogram mass is 13g. What force works against that? We call it T. The tension in the string works directly against it. Okay. So if you're an object and you weigh 80 kilograms, let's say, okay, you're going to weigh 80g, and your 80g is going to be acting directly downwards. And if you're not going anywhere, let's say you're suspended by a rope, this means that your tension in the rope upwards also has to be equal to 80g. Okay? Now, as it turns out, this isn't a stationary system, so it's moving. So that doesn't necessarily need to be the case this time around. So you're going to do Newton's second law for two different masses. Okay? So here's what you're going to write down. You're going to start off with the 1 kilogram mass, and it's good to label which one's which. Now, MA. Now, which way is MA going for this one? Up or down? Up. MA up equals, that means the force you have a choice. You're either going to use the 13g or the T. But which one's winning the battle for the 1 kilogram particle? Is the tension bigger than the weight, or is the weight bigger than the tension? For this one, tension's bigger than weight. I'll tell you why. Because it's going upwards. The red arrow going upwards has to beat the green arrow going downwards to cause the 1 kilogram mass to rise. Okay? So it means that MA is a positive number. It means you got to start off with the bigger number, which is going to be your T. And then the second number, which is what you're taking away from it, is the minus 1g going downwards. Okay? Next thing you're going to look at, we're then going to replace M with 1A, so it's going to be 1A equals T minus 1G. Now for the 13 kilogram mass, it's the opposite. MA, which is going to be 13A, because it weighs 13 kilograms, it's going up or down the force for the, the acceleration for the 13 kilogram mass, up or down? Down. So you write an arrow going down above it. Just help you keep track. Okay. What force is also going down, causing the 13 kilograms to be driven downwards? So its weight of 13 g is driving it downwards. What's slowing it up in the opposite direction? The tension T, which is going upwards. Okay. So what we do next, guys, is we have a simultaneous equation. We have 13a. So we have what we're looking for first. We're looking for find the common acceleration. So we're looking to isolate a. So to isolate a, we're going to add them both together. So 13a, 13g minus t, add them both directly downwards, we're going to get 14a equals t minus t, cancels, 13g minus 1g is 12g, so 14a equals 12g, a is going to equal 12 over 14g, therefore it's 6 over 7g. Your common acceleration of both particles is 6 over 7g. Now, once we've done that, we now have to find the tension. Tension, using this equation here, tension equals A plus G. Tension equals 6 over 7G plus G. T equals 13 over 7G. Is that alright? 13 over 7G. Okay. So, just to look at this, guys, okay? Remember I said T equals 13 over 7G. The tension going upwards beats the 1G going downwards. That causes the 1 kilogram particle to rise. However, the 13 over 7G is no match for the 13G going directly downwards. This is why the 13 kilogram mass goes downwards. Okay? So it's just about forces up versus forces down. Try another one. You'll see they're all the same. A smooth fixed pulley has masses 1 kilogram and 6 kilograms hanging from either sides by means of a light inextensible string. So there you go, your two strings are here. And then we have particle A, particle B. We'll do the same thing as last time, 1 kilogram, 6 kilograms, okay? The system released from rest. After 1 second, the 6 kilogram mass is suddenly held. So that's interesting, right? Find the common acceleration of the two masses. So, see this extra information here? That doesn't matter for the time being because it doesn't affect how we do part 1. Part 1 is still the same as the last question, so we're going to drive ahead with what we did for the last question, okay? Tension goes upwards. Weight goes downwards as 1g and 6g. Acceleration goes upwards for 1g and downwards for the 6g. Okay, so what we're going to get next is this. We're going to start off with the 1 kilogram mass. Okay guys, 1 kilogram mass. Tell me what to start off with. MA. Is MA going upwards or downwards? For the 1 kilogram mass. Huh? Upwards, okay. This means you start off with an upwards force on the other side. What's the upwards force on the other side? T. And then you subtract the downwards force, which is going to be your 1g. Okay, and we know that m is equal to 1 in this case because it's 1 kilogram mass. There's your first formula made fairly quickly. Okay, second one, 6 kg mass. So MA, also known as 6A, up or down, guys? Down. What do I need to lead with on the other side? Huh? 6G, because 6G is what's driving your 6 kilogram mass downwards. Take away T. You're looking for the common acceleration, right, and not the tension this time. So you're looking for the common acceleration of the two masses. So what happens is the common acceleration of the two masses is add equation A to equation B. So A plus 6A, 7A. T minus T, 0T. 6G minus 1G, 5G. A equals 5 over 7G. Okay. Now, what happens is what happens here is that your 6G, your particle starts moving. So the 1 kilogram one moves upwards. No, don't want that. So what happens is your 1 kilogram particle moves upwards. So it ends up down here. This one here ends up going downwards. And so just something to be aware of. The amount of distance that the 1 kilogram mass goes upwards is the same distance that the 6 kilogram mass goes downwards. Okay? and that's your 6G there. Now, so we're going to look at what it says here. After 1 second, the 6 kilogram mass is suddenly held. So if we set up a UVAS system, and it goes, find their common speed when the 6 kilogram mass is held. So their common UVAS system is that you start off from rest, U equals 0, V equals I don't know what, A equals 5 over 7G, common acceleration, S equals we don't know, and T equals 1. So V equals U plus AT, and phi equals U plus AT will mean that phi equals 0 plus 57G times T, which is 1. Your velocity is 5 over 7G ms to the minus 1. Okay, now part after that is your 6 kilogram mass is now held, so that's now held. The minute it's held, what happens to the acceleration? Disappears. Acceleration caused by the string is 0. Okay? Now, acceleration caused by the string is 0, which means your tension no longer exists, which means the string is about to instantly go slack. Okay? Now, your 1 kilogram mass is moving with what speed at the moment? It's moving with 5 over 7G. What does this what force is this particle undergoing as well, or what deceleration is it now undergoing? Gravity. Gravity working against it. Okay? So you have a second UVAS system. Your second UVAS system revolves around the 1 kilogram particle. Its U is equal to 5 over 7G. Its phi, we're looking for the maximum height, aren't we? So what will V be equal to? Has to equal 0, because you're talking about the 1 kilogram mass rising, then stopping, and then coming back down again. So its V has to be equal to 0. Okay? Its A value, minus G, S and T. The whole point of this question is to find out what S is. We're going to use phi squared equals U squared plus 2AS. And then we're going to use 0 equals square that, you get 25 over 49 G squared, right? And then 2AS is going to be minus 2GS. So then bring it over the other side. 2GS equals 25 over 49 G squared. One of those G's with that G there. S equals 25 over 98 G. Now, do you know the way the G is 9.8? G over 98 is the same thing as 9.8 over 98, which is a tenth. Okay, so we can just change that to 25 over 10, which will give us a rise of 2.5 meters. Everybody happy enough with that? 2.5 meters. Okay. What we're going to do is, there's a 4 kilogram mass in the middle, and like last time, we're going to make a prediction on what's going to go on here. Can anybody make a prediction on what's going to go on? Acceleration wise, that is. We're predicting the 10G particle will go downwards. We're predicting the 4G particle will therefore have to go to the right. And we're predicting that the 1 kilogram particle will most definitely have to go up. We know that there's two different forms of tension. We're predicting that this tension has to go, it goes upwards relative to the 1 kilogram particle. However, according to the 4 kilogram particle, tension is pulling it backwards. Imagine you have a weight attached to you and you're like running and you just feel something pulling you back like a bungee cord. Some form of tension. So according to the 4 kilogram mass, that's pulling it to the left. Okay? This here is going to be 1G. Let's go to the right hand side. 10G acting downwards. We're going to call this tension S because it's a different tension to the other tension to the left. Strings, plural, not string, singular. Okay? So S goes straight up. And according to the 4 kilogram particle, which way is S going to be dragging it, left or right? Right. Okay, if any of us ever did a sort of like a zip line downwards, if somebody ever pulled a string and the guy's over the hill, it'll pull you over the hill. Okay? So it literally, the tension would cause you to fall over the hill. Okay? So that's why it's going to the right. Now, you're going to break up each one individually. There's one thing I haven't. Table is smooth. So if the table is smooth, there's no frictional forces to take consideration of at the moment. Okay. So we're only considering the 4 kilogram particle going left and going right, nothing else. Now, let's have a look here. Start off your 3 equations. Start off with the ones we find easy. The ones we find easy would be this one here. So for the 1 kilogram mass, okay, MA, which is the same thing as 1A, equals, is it which one's winning, tension or weight? Which tension's causing to go upwards? So MA equals tension minus your weight going downwards, which is going to be T going upwards minus 1G going downwards. That's equation 1. Equation 2, your 10 kilogram mass is going to be SMA, which is 10A, common acceleration. In this case, weight is beating tension, so we're going to go 10A going downwards equals 10G minus S. This time, these two equations aren't relatable. Why are they not relatable anymore? The S and the T, the two different tensions, okay? That's where your third equation comes in as almost like a link equation. So we're talking about the 4 kilogram mass, okay? Now the 4 kilogram mass, we'll just have a closer look at it in isolation. T going to the left, S going to the right. Overall, your acceleration goes to the right. It's 4 kilograms in weight. MA going to the right equals S going to the right minus T going to the left, opposing it. Okay, so therefore 4A equals S minus T. And there is your link equation. Okay, so let me show you how to use this. Pick either S or T to get rid of. Doesn't matter which one. For convenience sake, I'll use S. 4A plus T equals S. Then isolate this S here. And then you can say that 10A equals 10G minus bracket 4A plus T. That minus 4A will go over the other side as a plus 4A, creating 14A. And that will be 10G minus T. Now the two equations are now relatable to each other. So we're going to add them together. So we're going to say that's 14A equals 10G minus T. Tensions get added together. And we're going to get 15A equals 9G. And then A will equal 9 over 15G, which is the same thing as 3 over 5G. Everybody happy enough with that? Common acceleration if it's smooth, right? Now, let's go back when the friction happens, okay? So we're just going to go back to the start of this now. Back before all this happens. So, just going to... Okay. We're now going to go back up to the formation of the 4G equation, okay? There's no frictional force applied, okay? Can anyone in the class tell me which way is the frictional force going to apply here? It's going to apply to the left. And what is the frictional force again? Friction equals mu r. Now, we have to find out what the R value is. Can anyone in the class tell me what the R value is? R in this case is going directly upwards. What goes directly downwards? 4G. The table is supporting your 4 kilogram weight. The 4 kilogram weight is neither rising above the table nor sinking into the table. Therefore, R equals 4G. And we know that our mu is our coefficient of friction, which tells us how much of our weight actually gets affected by friction, which is going to be our 2G. So you modify this equation here to include a 2G going to the left as well. Okay, so it's exactly like the last question, except this time I'm going to attach a minus 2G to represent friction at the end going to the left. Now when that happens, it's going to be 4A equals S minus T minus 2G. Like last time, we're going to isolate S. So 4A plus T plus 2G equals S. That equation there can now be substituted in for this S value here. So what we're going to get is that 10A equals 10G minus, open bracket, 4A plus T plus 2G. That is going to become 10A equals 8G minus 4A minus T. Is that right? Now, going to do next is bring the 4A over the other side. And we're going to get a 14A equals 8G minus T. Now, what do you think the friction should do relative to the last answer? The friction should slow down the acceleration, shouldn't it? So we're expecting a lower acceleration than last time. That's how you get a good feeling if you're right or wrong, if it affects it in the correct way. So put in, compared to the 1A equals T minus 1G, we're now going to get 15A equals 7G. Then A equals 7 over 15. Last time it was 9 over 15, wasn't it? So we've been affected by a factor of 2 over 15G. Okay.